Humans have always looked up to our mother star, the Sun. Solar telescopes have been around for centuries, and 44 years ago one of the very first satellites carried a solar observatory. Driven by a powerful energy source deep inside, the Sun emits energy in the form of light and energetic particles. Fortunately, here on Earth, we are screened from most of the dangerous parts of this radiation by our atmosphere and the Earth's magnetic field. While the Earth's atmosphere protects us from most of the Sun's energetic radiation, it also stops us from observing the outer atmosphere of the Sun, the so-called corona. The corona emits light mainly in the ultraviolet and X-ray parts of the spectrum. To understand how this outer layer of the Sun works and why temperatures there can reach 1,000,000 degrees, we have to go above the Earth's atmosphere. This is where the Solar Observatory SOHO is located, 1.5 million kilometers away from Earth.
By having images in different parts of the spectrum, we can sample the different layers of the atmosphere. So you can imagine the Sun like an onion, and we can peel off each layer after the other by looking at the different images that we have. And doing that, we can get a better understanding of how the Sun is built up.
SOHO was launched just over 10 years ago. Built by ESA and put into space by NASA, both space agencies have since been harvesting spectacular data. The most spectacular solar phenomena are coronal mass ejections, massive eruptions which hurl large amounts of energetic particles into space. When directed towards the Earth, they cause the ionization of atoms in the upper atmosphere and can produce spectacular aurorae borealis. On the downside, these events can be so powerful that they damage satellites and have been known to take out power lines. But it's not all bad news. Today, round-the-clock observations of the Sun by SOHO make it possible to give advanced warnings of imminent storms of solar particles. This growing area of research is called space weather forecasting.
The Sun is a huge thermonuclear reactor. In the core of the Sun, hydrogen is fused into helium, and that unleashes a huge amount of energy. The Sun is a very hot ball of gas, where electrons move freely and create magnetic field. And this magnetic field connects different parts of the Sun, and that governs the dynamics.
As always, reality is complex, and theories do not always match reality. The data amassed from SOHO over the last 10 years has helped scientists to discover what's happening inside the Sun and why its behavior is constantly changing. We need to understand these phenomena in order to assess their possible impact on our lives. What we know is that the Sun will keep on burning for some billions of years to come, and that during this time it will remain perhaps the most important factor in determining our living conditions, our energy supply, climate, and, last but not least, our well-being.